I am Ms. Tediteku Mudise, Subject Advisor for Natural Sciences and Technology, Grade 4, 5, 6, and Natural Sciences, Grade 7. I am from Motewa District. Today I'm going to present for you acids, bases, and neutrals for the grade 7s. And it is as follows. Just a brief introduction towards what I'm going to present today. Just a brief introduction towards what I'm going to present today. Let us look at the keywords. The keywords are sweet, sour, bitter, salty, acids, bases, neutrals, corrosives, and alkalis. Taste of substances. We can easily distinguish between 4 different tastes. The following tastes: sweet, sour, bitter, and salty. Humans use their tongue to distinguish between 4 tastes. The sense of taste plays an important role in our survival. Certain poisonous plants taste very bitter. This diagram illustrates a human tongue. Let's look at it. When you look at the back of it, we've got the taste buds that are responsible for bitterness. Just behind it, sour taste. The next one is where we can be able to test salt. And just at the tip of it in front, that's where we can be able to test substances that are sweet or chemicals that are sweet. Properties of acids, bases, and neutrals. Let us start first with acids. Acids, bases, and neutrals are important group of chemicals as we use them in our everyday lives, in particular at home. They have distinguished properties. Many foods and household chemicals can be classified as acids, bases, and neutrals, depending on their properties or what you call the characteristics. We actually use chemicals every day in our homes, e.g. to clean up our clothes, washing our hair, even cook our food. Properties of acids. Acids, actually, they taste sour. There's a very distinct taste for most of the people. The second one, they're so rough. A rough feeling when you contact with the skin. You can feel that itchiness when you can come in contact with an acid. They are corrosive. Many acids are dangerous to taste or to feel. That is why it is advisable that don't taste any chemical that you come across. Some of them can be so dangerous. Properties of the bases. Substances like washing powder, soap, bleach are examples of bases. How do you identify if a substance is a base? They are always slippery. Bases have a slippery feeling when in contact with the skin. For example, a washing soap. We are also having the bases that are very dangerous. And these bases can also be corrosive, can cause a serious harm to our skin when come in contact with. Take note that neutral substances are neither acid or no bases. Let me also bring the following to your attention. Number one, we have strong acids and also weak acids. Number two, we are having very strong bases and also very weak bases. Strong acids, we don't normally find them in our houses or at home. They are kept safe and away from us. We got what we call the indicators. Let me start with this one. We got what we call a universal indicator. You can use it to test if a chemical or a substance is an acid, a base, or a neutral substance. Number two, you can also use a special one from a red cabbage. You just cook it. After cooking it, you can use its sauce to test if a substance is an acid, is a base, or a substance is a neutral. Let's take a look at these ones. This is what you call a blue litmus paper. A blue litmus paper, you can use it to test if a substance is a base, if a substance is an acid. Now, let me give you an example. When you take a blue litmus paper and you dip it in an acid, immediately it will change its color from blue to red. Then you know that the chemical or the substance that you have tested is an acid, but it remains blue in a base. Right. This one is what we call a red litmus paper. A red litmus paper, you can also use it to test if a substance is an acid, a base, or a neutral. Now, if you take a red litmus paper and you dip it into an acid, it will never change its color. It will remain red. But if you take a red litmus paper and you dip it in a base, it will change its color from red to blue. Then we know that that substance, it is a base. Right, let's go back to our presentation. Litmus papers, as I have indicated to you, we got red and blue litmus papers. Red litmus papers stays red in an acid and in a neutral substance. A blue litmus paper stays blue in a base, But when you take a blue litmus paper, then you dip it in a neutral substance, it will turn what? Blue, to indicate that that substance is a neutral. Take note of this. Blue litmus papers changes red when in contact with an acid, and a red litmus paper changes blue when it is used in a neutral substance. Let me repeat what I'm saying. What I'm saying is this. We got two types of litmus papers. We got two types of litmus papers. The first one is a red litmus paper, and the second one is a blue litmus paper. As I'm saying, the first one is a red litmus paper and a blue litmus paper. Good. And I said to you, red litmus papers stays red in an acid and a neutral. But a blue litmus paper stays blue in a base and a neutral. Take note that blue litmus paper changes red when in contact with an acid, and red litmus papers changes blue when they are in a neutral substances. Good. Let's look at the picture in front of us. As I said that, when you look at it on your left-hand side, it is what we call a red litmus paper. I'm talking about this one. This is a red litmus paper. Correct. And then, on the right-hand side, we are having a blue litmus paper. I'm talking about this one. Here is a blue litmus paper. Let us look at the picture again. They are used this way. Look at the left. Acids. On the right, bases. Let's look at the acids on the left. They took a blue litmus paper and dip it in an acidic substance. And immediately, as I've indicated before, the blue litmus paper changes its color into red. The base on the right-hand side, a red litmus paper, when dipped into a base, immediately is going to change its color and becomes blue. When you're performing a practical task. Right. Acid-base detection through litmus paper, blue and red, and universal pH paper. We can dip them in different solutions. Then you can use this scale to determine whether a substance, is it an acid, is it a base, or it is a neutral substance. Good. I'm going to perform a practical task. I'm going to perform the practical task, but let's just go through the slide first before I go to practical task. We are going to use water, ordinary tap water. We are also going to sample with Sprite as drink. We are also going to use vinegar, is there. Also, a shampoo is there. But let me make you aware that I'm going to use the universal indicator that I have created from a red cabbage. Then I'm going to use it to test if a substance is an acid, a substance is a base, or a substance is a neutral one. Right, let's take a look. Good. In front of me here, I'm sitting with this stand. Let's have a close look at it. All right, let me take out these ones. Good. Number one, I'm going to pour what? Water inside here. Number one, I'm going to pour water. Good. Number two, as you can see, it's a vinegar. Number two, it's a vinegar. Number three is what? Our Sprite drink. The next one, a shampoo. I can also add a bleach. I can also add a bleach in these chemicals. Good. Let me take this one also and add a bleach inside. Right. Step number one, water. This is an ordinary tap water. I take an ordinary tap water, I pour it inside here. Good. The second one, it's our vinegar. Here it is. It's our vinegar here. The third one, you can take a look at it. It's our Sprite. Good. Okay. Let me put it aside here. You can see it is a family shampoo 2-in-1. Correct. Right. We can also, as I said, use this Harpic bleach. Just pour it here. Correct. As we move on, I have indicated to you that I'm also going to use red cabbage to test them. Good. Now let us look what is happening here? Water. Let's look at it. When you look at the color of the water, it doesn't change to any color. It takes the color of a red cabbage. It means it's a neutral substance. Let's look at this one. Right. This one is a vinegar. Look at this. Look at the color change of a vinegar. Look at it. Immediately when I pour inside a red cabbage, it changes red. It means it is an acid. Let's test this one. Sprite. Look at it closely. 1, 2. There is a reddish color at the top there. It's starting to change its color. It means also it is an acidic substance. Look at it also. Good. It's our shampoo here. Let's have a look. Let me just shake it quickly. Let me add let's look at it. Let's get a color change. Let's look at the two. This one is an acid. This one, the color remains the same as the base. The last one. Also look at this color change here. From a bleach. Good. Right. We can also compare this experiment using the following. Let us demonstrate using our litmus papers. Let's demonstrate using our litmus papers. Good. The first one, I'm using a vinegar. Then it's a Sprite. Our tap water. Our tap water. Good. Then I'm taking the first one. It is a blue litmus paper. I'm putting it next to our vinegar here. The second one next to Sprite. Then the next one, water. Thank you. Let us look at the color change to our substances. Let's look at the color change. to our substances. Number one, thank you. Number one, I'm going to use a blue litmus paper. And please try to remember what I've said before. What is the color change when a blue litmus paper came into contact with different chemicals? For an example, the blue litmus paper, I'm dipping it inside a vinegar. Let's look at it. Look at this one. A blue litmus paper inside vinegar immediately changes its color into red. This simply means that vinegar is an acid. The other blue litmus paper, I'm using it where? Inside Sprite. Let's have a look at it. Immediately, also, it changes color to what? Red. This tells us that Sprite is an acidic substance. Right, let's have a look at this one. Ordinary tap water using a blue litmus paper. Let's have a look. The litmus paper remains blue. It is a neutral substance. All right, let me take them out here. Let me put them here. Correct. Now I'm going to use in each and every chemical a red litmus paper. Good. Here's the first one for vinegar. The second one for our Sprite drink. The third one for tap water. Right. Let us have a look. I'm taking a red litmus paper. I'm putting it inside vinegar. No color change. It confirms our test that vinegar is an acidic substance. Let's carry on. I'm taking the red litmus paper. I'm using it inside Sprite drink. Let's have a look. What is happening there? Take a close look. Good. Clear. No color change for the red litmus paper. It means Sprite is an acidic substance. Ordinary tap water a blue litmus paper, a red litmus paper, we know that our water is a neutral substance, right? No color change then. Let's carry on. Let's move on quickly so. Let me put these things aside. Back to our presentation. You can design your own thing that you're going to use when you test. Either a substance is an acid, a base, or a neutral. You can design a worksheet the way you want it to be. Let us look at this one closely so. I said on the left-hand side, vinegar. I can also test the lemon juice with it. Shampoo. A dishwashing liquid, bleach, or water. Then at the top we can say the color of red litmus paper, color of blue litmus paper that you're going to use. Conclusion, whether a substance is an acid, a base, or neutral. One thing that I would like to ask you is that please make it a point sure that you are using the material that are around the kids. It means that can be easily accessible at home. No expense needed. Good. Let me go back and quickly summarize what I've said today. I said we got our key words that we need to know and understand them. Then they are so important when we are dealing with acid bases and the neutrals. I also talked about the taste of a substance. We can distinguish between 4 different tastes, either sweet, sour, bitter, or salty. Humans use their tongue to distinguish between the 4 tastes. The sense of taste plays an important role in our survival. Certain plants can be so poisonous. Also, I've shown you a diagram of a human tongue where the taste buds are. Tasting what? The bitterness, the sourness, salty, and sweet ones. Acids, bases, and neutrals are important group of chemicals as we can use them in our everyday lives. They have different distinct properties. Many foods and household chemicals can be classified as acids, bases, and neutrals, depending on their properties. This simply means that each and every chemical got its unique properties. And if they share common properties or characteristics, it is easy to classify them as acids. You can classify them as bases. We can classify them as neutrals, depending on the common characteristics that they are sharing. We actually use chemicals every day in our homes, e.g., to clean our clothes, washing, our hair, or we can also use the chemicals for cooking our food. Water, vinegar, we can use them for cooking. I also said that acid got its own properties. Acids are sour, they are rough, they are also corrosive. And I said the bases, they feel slippery, they are also dangerous. And I said to you, please take note that neutral substances are neither acids nor bases. We got indicators. Indicators are special chemicals to determine whether a substance is an acid or a base. I said you can also use a red cabbage to indicate whether a substance is it a base, a neutral, or an acid. I've shown you the pictures of different litmus papers, the red and the blue litmus papers. Red litmus paper stays red in an acid and in a neutral substance. Red litmus paper, the blue litmus paper stays blue in a base and in a neutral. You've seen that. Take note that the blue litmus paper changes red when in contact with an acid, and red litmus papers changes blue in a neutral substance. These are the pictures. The red ones are the red litmus papers. The right-hand side are the blue litmus papers. These are the color changes. When dip it in an acid, the blue litmus paper will change to red. When you dip it in a base, the blue litmus paper, the red litmus paper will change to blue to indicate that the substance is a base. I said we can also use a pH scale to determine whether a substance is an acid, is the neutral, or it is a base. You can design your own worksheet. I gave you an example for practical tasks, whether a substance is an acid, base, or a neutral substance. At the end of this lesson, I'm saying to you that in order for a teacher or a learner to perform a practical task, it must be in a well-safe, ventilated laboratory. What is it that I'm trying to say? Please, never try this at home alone. It needs a very strict supervision of a teacher. With those few words, I would like to say to you, thank you very much. Thank you.